Section 3.2, linear equations in two variables. Earlier in the course, we considered linear equations in one variable. For example, the equation 3x minus 2 equals 10. And we were able to ask ourselves, is x equals 4 a solution of the equation? And we could answer this by substituting for the variable and checking to see if it gave us a true statement. 3 times 4 is 12, take away 2 is 10, and 10 does equal 10. So x equals 4 is a solution. Well, now if we had an equation with two variables, we have to consider a value for each of the variables. So if we thought of the equation 3x minus 2y equals 10, we could ask ourselves, is x equals 6, y equals 4 a solution? And we would check our work by the same process. 3 by 6 minus 2 by 4, is this equal to 10? 3 by 6 is 18, 2 by 4 is 8, 18 minus 8 is 10, 10 is equal to 10, yes. But now the statement x equals 6, y equals 4 is a little tedious. It takes a while to write. So we might instead ask ourselves, is the ordered pair 6, 4 a solution? Okay, so remember, the ordered pair is a shortcut to say x equals 6, y equals 4. We want to write the ordered pairs. All right, so try this out. Is 2, negative 2 a solution of the equation? Is 0, 5 a solution of the equation? All right, so 2, negative 2, we would have 3 by 2 minus 2 by negative 2 equals 10. That's 6 minus negative 4. 6 minus negative 4 is 6 plus 4, which does equal 10. So yes. Is 0, 5 a solution? 3 by 0 minus 2 by 5. Is this equal to 10? 3 by 0 is 0. 0 subtract 10 is negative 10, which is not equal to 10. So 0, 5 is not a solution of the equation. So now that we can find solutions, or we can identify solutions, it might also be useful to help determine solutions of the equations, and it will help us when graphing. So to graph linear equations in two variables, and other equations in two variables, we need to find several solutions to the equation, write the solutions as ordered pairs, plot the ordered pairs as points, and draw the line, or more generally, the curve that passes through the points. Now, a table of values is going to help us organize information in this process. Now, I've been mentioning this term, linear equation in two variables, and I thought I'd go ahead and define that more explicitly here. A linear equation in two variables is an equation of the form ax plus by equals c, that should have been a plus there, ax plus by equals c, where a, b, and c are fixed numbers, called constants, and a and b are not both equal to 0. Now, the graph of a linear equation in two variables is a line. And I said, note the equation may appear differently. It might not always look like this exact form. But what we're looking for is, like linear equations in one variable, the power on x is the first power, the power on y is the first power. There's no divisions by variables, there's no variables to second or third or fourth powers, there's no square roots of variables. So now, let's look at how we can construct and complete a table of values. Take, for example, the equation y equals negative 2x plus 4. Let's complete the table of values. And what we have here is some x values have been chosen for us. So now if x equals negative 4, what would the value for y be? Well, what I'm going to do is replace x with its value. So then the y value would be negative 2 by negative 4 plus 4. The y value would be, so let me see, if x equals negative 4, right? We would have 8 plus 4, we would have 12. If x equals negative 4, y equals 12. Then I'll go to the next one. If x equals negative 2, y would equal negative 2 by negative 2 plus 4. Y would equal 4 plus 4. Y would equal 8. All right, and why don't you complete the other two parts of the table? If x equals 0, y would equal negative 2 by 0 plus 4. Y would equal 0 plus 4. Y would equal 4. And finally, if x equals 2, y would equal negative 2 by 2 plus 4. Y would equal negative 4 plus 4. And y would equal 0. So now let's look at this. We have this table completed, but now what is this saying? If x equals negative 4, y equals 12, that's an ordered pair. Negative 4, 12. Negative 2, 8. 0, 4, 2, 0. Let's graph the equation. So now it says graph the equation, negative 2x plus 4. Well, we've identified 4 points that are on the table, that satisfy the equation. Negative 4, 12. Negative 2, 8. 0, 4. And 2, 0. Now, I don't have any marks on here. I have marks, but I don't have any numbers. So let's just suppose that each mark means 1 unit. So I'll just put those ones there to remind us that each mark means 1 unit. So let me plot the points. Negative 4, 12 wouldn't fit here because these would only go up to 10. Negative 2, 8 would be here. 0, 4. 2, 0. Notice that those points appear to be in a line. So what we would do is draw the line that passes through those points. That was pretty poor there. All right, so there's the line that passes through those points. And it's nice to then also label it y equals negative 2x plus 4. All right, so let's look at another one. Complete the table of values for 3x minus 2y equals 12. And I got the table in a slightly different format. Doesn't matter. It's the same thing. All right, so now 3x minus 2y equals 4. If x equals 0, then I'd have 3 times 0 minus 2y equals 12. 3 times 0 is 0. 0 minus 2y is 12. 0 subtract 2y would be negative 2y equals 12. And dividing by negative 2, y would equal negative 6. So if x equals 0, y equals negative 6. And let's see, I'll do the last one. I'll do what if y equals negative 9? If y equals negative 9, we would have 3x minus 2 by negative 9 equals 12. 3x plus 18 is 12. Subtracting the 18 from both sides, 3x is negative 6, and dividing by 3, x would equal negative 2. So if y equals negative 9, x equals negative 2. Why don't you pause and fill in the other two spots on the table? Alright, if y equals 0, then we would have 3x minus 2 by 0 is 12. So 3x minus 0 is 12. 3x minus 0 is 3x. And dividing by 3, x would equal 4. And finally, if x equals 6, you would have 3 by 6 minus 2y is 12. 18 minus 2y is 12. Subtracting 18, negative 2y is equal to negative 6. And dividing by negative 2, y equals 3. Alright, so again, we have values for x and y that are based on this table. So let me just go ahead and write out those ordered pairs. Let's see, we have 0, negative 6, x then y. We have 4, 0. We have 6, 3. And we have negative 2, negative 9. So now that we have those points, we can graph the equation. Let me just rewrite them here. We have 0, negative 6, 4, 0, 6, 3, negative 2, negative 9. And again, let's use a scale of 1 on each axis. And I'll plot the points in black. 0, negative 6, 4, 0, 6, 3, and negative 2, negative 9. Now, if you've done this correctly, these points should appear to be in a line. Alright, so there's my rough line there through those points. So what I've just shown is how to take an equation and take a table that's been sort of set up for us and complete the table, write the equation to find the points to graph the equation. Alright, so now what if we had the equation? It just says now, graph the equation y equals 2/3 x minus 4. We aren't given a table. We aren't told where to start. Alright, well, let's put in a table then. Alright, so let me just do a little table here. A little xy table. Now, if we have the equation where you have one of the variables solved, the one of the variables is by itself, the easiest thing to do is substitute for the other variable. And so what I'm going to do is, and since the coefficient in front is a fraction, 2/3, I'm going to choose multiples of 3, because that'll make the arithmetic easy. So I'm going to choose 0, 3, 6, and 9. Alright, if x is 0, then y would equal 2/3 of 0 minus 4. Y would equal 0 minus 4. Y would equal negative 4. If x equals 3, y would equal 2/3 of 3 minus 4. 2/3 of 3, thinking of that 3 as a 3 over 1, y would equal 2 minus 4, which is negative 2. Now, if you continue with this process, with the other two, you should find that when x is 6, the y value is 0, and when x is 9, the y value is 2. Plotting these points, again using a scale of 1 on each axis, 0, negative 4, 3, negative 2, 6, 0, and 9, 2, all are on a line. All right, so plotting the point, we have the points plotted, and drawing the line through those points, that looks reasonable. This is the line y equals 2/3 x minus 4. All right, graph the equation. Negative 2x plus 5y equals 20. When we have an equation like this, where we have neither variable solved for, what I generally do is set up a table and do an x for 0, a 0 for x and a 0 for y, and then I'm going to choose one other value that I'm going to wait on for a moment. All right, so first, if x equals 0, then we would have negative 2 times 0 plus 5y is 20. Negative 2 times 0 is 0. 0 plus 5y is 5y. So 5y equals 20, dividing by 5, y equals 4. So we have the point 0, 4. Now, if y equals 0, we would have negative 2x plus 5 times 0 is 20. So negative 2x plus 0 is 20. So negative 2x is 20. So that means that x, dividing by negative 2, x is negative 10. So now, I have to pick another, I like to pick one other point. All right, so what I might do now is pick some other value for x. How about 5? Let's pick x equals 5, and just want to pick some other number. So if I let x equal 5, and I'll do this work, let's see, I'll do this work up here. If x equals 5, then you'd have negative 2 by 5 plus 5y is 20. Negative 10 plus 5y is 20. Adding 10 to both sides, 5y equals 30. Dividing by 5, y equals 6. So now I have 3 points, again using a scale of 1 on each axis. 0, 4, negative 10, 0, and 5, 6. And those 3 points do appear to be on a line. Let's draw the line through the points and label it. All right, so now here's one I would like for you to pause and try on your own. All right, so if y equals negative 3/5 x plus 1, again, I'm going to set up a table. I'm going to choose some values for x. I'm going to choose negative 5, 0, and 5. And again, I'm choosing these values because they are multiples of the denominator, of that fractional coefficient. Alright, so if x is negative 5, then y would equal negative 3/5 by negative 5 plus 1. Alright, so if you go through this arithmetic correctly, negative 3/5 of negative 5 would be positive 3, and 3 plus 1 is 4. If x equals 0, and that one's easy. Negative 3/5 of 0 plus 1 would be 0 plus 1, which is 1. And if x equals 5, negative 3/5 of 5 would be negative 3 plus 1, which would be negative 2. Alright, plotting those 3 points, and remember we should see a line if we've done this correctly. Negative 5, 4, again using a scale of 1 on each axis. Negative 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, negative 5, 4, 0, 1, and 5, negative 2. And those 3 points do appear to be on a line. Drawing the line passing through those points. Alright, roughly there's our line. Y equals negative 3/5 x plus 1. Alright, again, I would like for you to pause and try this one out on your own. Alright, x minus 4y equals 6. So I'll set up a table here. And since it's in that more standard form, substitute a 0 for x and a 0 for y. Alright, if x equals 0, then we would have 0 minus 4y is 6. So negative 4y equals 6. So y would equal 6 over negative 4, which reduces to negative 3/2. If y equals 0, then we'd have x minus 4 times 0 is 6. X minus 0 equals 6. X equals 6. So we have these 2 points, 0, negative 3/2. Now if we use a scale of 1, then remember negative 3/2 is negative 1 and 1/2, or negative 1.5. So it would be about here. And then 6, 0 would be here. Then we would just maybe want to find one more point just to be sure. So how about we choose a negative value for x? How about negative 2? If x is negative 2, then we would have negative 2 minus 4y is 6. Adding 2 to both sides, negative 4y is 8, and dividing through by negative 4, y would be negative 2. So negative 2, negative 2. Plotting that point, and again, we do appear to have 3 points that are on a line, so we'll draw the line through the points and label it as x minus 4y is 6. Alright, graph the equation 2x minus 7y equals 0. Now if we went about this like we did the previous exercise, and we started off with zeros on the x and the y, well, if we let x equal 0, if x equals 0, then we would have 2 times 0 minus 7y equals 0. And so we'd have 0 minus 7y equals 0. So negative 7y equals 0, and dividing by negative 7, y equals 0. So if x equals 0, y equals 0. Well, that means that if y equals 0, x would equal 0. So all we have really is 1 point. And that's not enough. We have to find another point. So what is generally recommended is what you would now do is take this equation and solve for y. Literally solve the equation for y, isolating that variable. So subtracting 2x from both sides, we would have negative 7y is equal to negative 2x, and dividing through by negative 7, we would have y equals 2/7 x. So now what we would do is choose another value for x, like 7. Why 7? Because look at the denominator on the coefficient of x. It's going to make the arithmetic easy. Alright, so if x equals 7, then y would equal 2/7 of 7. Y would equal 2. And plotting the point 7, 2, we can draw the line through the points. Alright, let's finish off this section with an application. It says, today the amount A of garbage in pounds produced after T days by the average American is given by A equals 4.5 T. Alright, it says now graph the equation for T is greater than or equal to 0. Alright, so graph the equation. I'm going to set up a table. So T A. Now, why did I choose to do it like that? Well, look at how it's set up here on the grid. It has T where we would normally place X, and it has A where we would normally place Y. So I'm going to set that up like X and Y. T, then A. So now let me graph the equation. Well, let me get some values in here. How about with T equals 0? And now I'm just sort of looking at the values here. If A equals 4.5T, that's pretty easy. I just have to multiply by 4.5. And so the decimal number, I'm going to multiply by like 10 and then 20. Get a few points in here. Alright, so if T equals 0, A would equal 4.5 times 0, which would be 0. If T equals 10, A would equal 4.5 times 10, which would equal 45. And if T equals 20, A would equal 4.5 by 20, which is 90. Plotting those points, 0, 0, 10, 45, and 20, 90. I can plot the points. I can plot the points and draw the line through the points. Part B asks us, how many pounds does it take for the average American to produce 100 pounds of garbage today? So, to produce 100 pounds of garbage, that's telling me that A is 100. When A equals 100, 100 would equal 4.5 T. So then, dividing both sides by 4.5, and using a calculator or long division, you should find that T is approximately 22.2. So about 22 days. Now, just to sort of check our work here, let's look at the graph and notice that when a equals 100, right, when the a value is 100, what is the t value? 22 appears to be reasonable. Okay, so this work appears to be reasonable.